Okay, this is probabilities of a permutation and a combination. The problem says there are 7 people taking part in a raffle. Anne, Bob, Elsa, Jim, Lena, Ravi, and so. Suppose that prize winners are randomly selected from the 7 people. Compute the probability of each of the following events. Event A is Jim is first prize winner, so is the second prize winner, and Elsa is the third prize winner. Because their order matters, if you win first prize, you won't win second prize. It's a different situation if you win second prize and somebody else wins first prize. That's a permutation. So event A is going to be a permutation because order matters. Order matters. And then the second one says, event B, the first 3 prize winners are Elsa, Jim, and Anne, regardless of order. So regardless of order, that's a combination. Combinations, order does not matter. And to explain this a little better for you so you can understand, I actually made up a little example over here, so I'm going to switch my papers. Okay, so I wrote permutations, combinations. And let me just do this first here. Okay, so order matters. So let's say we have 3 people, Bob, Sue, and Dan. And you are looking for somebody to be president and somebody to be vice president in this little 3-person club, okay? So you've got some situations here. You can have Bob as president and Sue as vice president. That's one situation. Or you can switch the two. Sue can be president and Bob can be vice president. That's a different outcome because they're holding 2 different positions. Then I could do Bob as president and Dan as vice president, or switch those two, say Dan is president and Bob is vice president. And then the last pair is Sue with Dan, so Sue is president, Dan is vice president, or Dan is president and Sue is vice president. That's 1, 2, 3, 4, 5, 6 outcomes because order matters. They're holding very specific positions, so the order in which they do it matters. But if you had these same 3 people and you were like saying, okay, I just need 2 people to work on a committee. I just need 2 of you to get together and who knows, maybe they're just going for pizza for the meeting, who knows, but they're not holding any special position. Order doesn't matter. So when I look at these same combinations of Bob with Sue and Sue with Bob, those are the same 2 people. That's actually just one combination. Bob and Sue together. Doesn't matter who's doing what. They're both doing the same thing. Same thing with here. Bob and Dan or Dan and Bob, those are the same 2 people. Sue with Dan, Dan and Sue, those are the same 2 people. So I really only have 1, 2, 3 possible outcomes on a combination because order doesn't matter. That's the difference between permutations and combinations. So you kind of have to think about the word problem and ask yourself, does order matter? Are these people being put in a specific order? Kind of like at the racetrack, horses are win, place, and show. And if you bet on win, place, and show, they have to come in that order or you don't win. So that's a permutation, win, place, and show. I don't go to the racetrack much, so I'm not thinking if there's any combinations there that you can go with. Sorry, didn't think that went through enough. But anyway, back to our problem. All right. Get rid of that. This one's actually asking for the probability. So if Jim is first place and so is second and Elsa is third, there's only one way that that can happen. But we want to know that one way out of all the ways that can happen. all the ways that you can have a first prize, second prize, and third prize position out of the 7 people. So that's a permutation. So it's going to be 7 people, any combination of 3, and I just realized I put the C right there. Sorry, it's a permutation. 7 people, and I need permutations of 3 at a time. First place, second place, third place. Now, I use a calculator for this. Here's my calculator. And let me stand up and see how this is showing in the screen. There it is. Most calculators have or scientific calculators have a permutation button somewhere in them. And mine is hidden within my, PRB, probability. If I click on PRB for probability, it shows choice 1 is NPR, choice 2 is NCR, and choice 3 is factorials. I'm doing number 1, so I'm going to clear that. I'm going to hit 7, probability, choose number 1, and then tell it 3. And it's actually going to figure out how many ways out of these 7 people can you have first, second, and third places. When I hit enter, there's actually 210 different ways. If I tried to write them all out like I did with the 3 people, what was it, Bob, Sue, and Dan, it would take me forever. Because you can do Ann, Bob, and Elsa, Ann, Bob, and Jim, Ann, Bob, and Lena, Ann, Bob, and Ravi, Ann, Bob, and so as first, second, and third, and then go on from there. It would take all day to write them all out. So there's 210 ways this can happen, right? But they wanted the probability of it happening. There's only one way Jim can be first, so can be second, and Elsa can be third. There's only one way that can happen out of the 210 ways, period. And then the second one is the first 3 prize winners are Elsa, Jim, and Ann, regardless of order. So this is just a combination. Combinations, there won't be as many ways for this to happen. We're still dealing with 7 people, but I'm looking at combinations of 3. And so I go back to my calculator, 7, oops. I go to my probability button and I hit number 2 because that's NCR with a 3. I should get an answer smaller than 210, and I do. It's 35. So there are 35 ways that Elsa, Jim, and Ann can come in as the first 3 prize winners. There's 35 ways 3 people can come in as the first 3 prize winners, and Elsa, Jim, and Ann would only be one of those. 1 out of 35. Sorry about that. My mouth got messed up. So that's that. I hope that helps.